All right, guys. So in this lecture, we are going to look at some of the PCH 201 practical questions, the one they wrote last year. And I'm going to be solving the question generally on how to calculate or how to get your milli equivalent. All right. So we have the question here that says, now listen, titration is standardization. When we talk about standardization, my dear student, what we are looking at, I never plug my writing pad, I'm coming. Titration is standardization, my dear students. I want to talk about standardization. Sorry about that. Okay. I was saying that titration is standardization. I want to talk about standardization. Standardization is a reaction between something we call a titrant and a titrand or titrate. Standardization is a reaction between a titrant, or a titrate. Now, what do we mean by that? When we talk about standardization, we are trying to use something that we know to determine something that we don't know. That is what standardization is all about. Are we getting? So you may be asked to define standardization. Standardization is the process of getting the exact concentration of a solution. That is standardization. The process of getting the exact concentration of a solution is standardization. A solution with a known concentration, is called a standard solution. It's called the standard solution. Now, my dear student, why do you standardize? Is to get the exact concentration. Because what we are doing in titration generally, my dear student, you are using something that is known to confirm the unknown. If you take that one again, I say what we dey look for titration. We dey use wetin we know, which we call the known, to confirm the what? Unknown. The one that you know is called the titrant. Why the one that is unknown is called the titrant or titrate. The one that you don't know is the titrant. The one that you know is the titrant. You are using what you know to confirm the unknown. That is what titration is. Titration is a form of standardization. Now, how does it work? Let me give you an example. Let us say you have 5 cups of beans, an unknown cup of rice. Cup of rice you don't know, X. But you know that we have 5 cups of beans. There is something you know. Now, my dear student, let us say you want to cook rice and beans. For every 1 cup of rice, for every 1 cup of beans you take, you must take 1 cup of rice. You know the amount of beans you have remaining, but you don't know the amount of rice you have remaining. But you know that for every 1 cup of beans, this here is your beans. You are taking 1 cup of rice. So, my dear student, if you take, at the end of the day, 1 cup of beans first, you took 1 cup of rice. 2 cup of beans, let's say another 1 cup of beans, another 1 cup of rice. Another 1 cup of beans, that is 3. Another 1 cup of rice. You took 1 cup of beans, you now discover that rice don't finish. Are you getting it? You know that, yes, so we had 5 cup of beans here. Is that okay? But you don't know how much rice we had left. But when we now measure, you discover that for every 1 cup of beans, we are using 1 cup of rice, 1 cup of beans, 1 cup of rice, 1 cup of beans. We now took the 4th cup of beans, and you now discover that your rice are finished. What does that information give to you? It tells you that initially we only had 3 cups of rice present. Is that okay? It tells you that we only had how many cups of rice present? 3 cups of rice present. That is what standardization is all about. Now, how does it work? Let me give you an illustration. I've given you illustration with rice and beans. How does it work? You have what we call the titrant. We have what we call the titrant. And then we have what we call the titrate or analyte. Analyte is what you are looking for. Are you getting the amount of what you are looking for? Analyte, titrate, titrant. Now, my dear student, you have the titrant. The titrant is the one that is known accurately. When we say something is known, it means the titrant is the standard solution, because we say standard solution is the solution which concentration is accurately known. Why the titrate is the unknown. Is the what? Unknown. Now, by knowing there's a relationship between the titrant and the titrate. What is the relationship? Like we said, for every 1 cup of titrant you take, you only take 1 cup of what? Titrate also, which is like 1:1. That is the relationship you see due to the balanced equation. You know, most of this they require balanced equation. That relationship, like the one we did for cup of rice, cup of beans, we say it's always 1 cup of rice, 1 cup of beans. When we now come to chemistry, that thing now that equation when you dey write like sodium hydroxide plus hydrogen chloride to give us sodium chloride plus water, right? The ratio is what? 1:1. That is the relationship. Like the way they say 1 cup of sodium hydroxide supposed to react with 1 cup of what? HCl. Let us say sodium hydroxide now is the titrant, the one that you know. Are you getting it? Why aspirin? Aspirin is an acid. It's like HCl. Why aspirin is the unknown? Are you getting it now? By knowing how much of sodium hydroxide reacts, you should be able to calculate how much of aspirin is present there. That is what titration is all about. Using a standard solution to get to get something that you don't, the concentration you don't know. In this case, aspirin. By knowing how much of the standard solution, which is the one you know, by knowing how much of beans you reacted, you were able to calculate how much of what? Rice that was present. By knowing how much of sodium hydroxide that reacted, you are able to calculate how much of aspirin that is present. And this involves a whole lot of calculation. Are you getting it? But now it's just the general idea. Now listen. It is expected. I don't know why this one is like this, but we just manage it. Now, exactly. Now, it is expected, my dear students, listen, that this sodium hydroxide when they use here is pure. And if they tell you say na 0.1 mole of sodium hydroxide dey here or 0.1 molar sodium hydroxide dey here, na that 0.1 molar sodium hydroxide na dey. E no dey much, e no dey less. E no be 0.12, e no be 0.09. Are you getting it? That one na that one they call standard solution. So standard solution na the one wey be say the concentration you know and say na wetin dey there o. For instance, na that your rice. Are you getting it? You know say that rice when dey there now, how many cup? 5 cup o. Do you get it now? Now by so doing, you will be able to now tell the amount of what? Aspirin, because you know say this one a perfect person, so you compare. Are you getting it? But what if a situation where this baba when we say we dey talk say e dey perfect, e no dey perfect? It means anything when you measure with this one aspirin, e no go give you correct answer. Because wetin the one wey we say we dey feel say na im be the better thing, na im be the correct thing, e no dey actually, e no even dey correct in the first place. E just be like the cup wey take dey measure your rice. Let me use that one as an analogy again. The cup wey take dey measure your rice. That cup, it is expected that that one basket, once you measure am, na one basket of rice dey there. Because that one now we don know, say we don standardize and say, okay, na one basket na this thing dey measure. Are you getting it? It is known, standardized. We don't standardize and say this na one basket dey measure. But a situation where that one basket not be one basket again, they don't panabit am. You can't see some places push go inside. Like you see say the thing no dey neat. Some places don scatter scatter. Instead of this thing to dey like this, you can't dey see am dey like this. You know say when you measure, the thing don squeeze, e no go give you that exact one basket again. So it is expected that this one when you dey use, dey compare this one, is pure, is okay, is clean. But most of the time, not be always so. This one, sometimes, see them, they get your own score, which is the titrant. So the process now, when we say you go take now know the amount, or the process when we say you go take, like, try and get the exact concentration of this titrant, is what we call standardization. Do you understand what I just said? Do you understand? What did I try to tell you now? They say, listen, this one now when you want use take compare. This one when you want use take compare. Now this one we know standard solution. Are you getting it? When you want to compare, it is expected that it is pure, it is okay, everything there, the exact concentration is known. But most time not be always like that. It just be like the way I use a cup of that basket of rice. Not be that basket. Sometimes some people they hit and it don't squeeze for body. When they measure like 2 cups don't come out. Because of the way the rubber when they take measure and be for you. Do you get what I'm trying to say? So that process of like, oh yeah, I'll bring that thing come. I beg. I don't like the way, madam, I don't like the way this thing, the way it squeeze. I beg. Use your hand, hit them, make the thing open. Those places when squeeze inside. For instance, let us say there's something it did like this before. Are you getting it? Now we'll come panabita. It's such a way when we say the thing will come day straight like this. That process of making it straight to ensure say one basket is what we call standardization. Because once we don't do this one to ensure say this one don't be okay, are you getting it? This one now will not be able to tell us what is here accurately. So what is standardization, my dear students? Standardization is the process of ensuring that, are you getting it? Something contains the exact amount. Is that okay? Or standardization is the process of getting the exact concentration. They may ask you that of a substance. That is what standardization is all about. The process of getting the exact concentration of a solution by comparing with a standard solution is called standardization. Is that okay? And that is what titration. Once you now standardize that solution now cannot be used to compare others. Is that okay? You be like, so you be person when say you know too good. Let me use another example. You know too good. They can't carry you come up for village. They put you for school. Your brain, everything don't pure. They don't straighten you. That process of straightening you to make sure say your conversation is wide. You're not going to talk like village man again, like me. You are now like very okay. That process of making you okay, so that when you can't go village now, they can't compare you. You see this guy. Now this one now be the kind of person we want for the society. It's what we call standardization. Is that okay? So how is this calculation done? The most important thing I want you guys to understand here is the calculation. Although I also want you guys to know the general idea behind it. Are you getting it now? We have two types of standard. We have primary standard and secondary standard. All right? You can go and browse what a primary standard is, what a secondary standard is. Okay, so we have the question here that says the standardization of 0.05 molar. Take note of these things when they give. 0.05 molar EDTA was carried out using 0.2 gram of zinc sulphate heptahydrate. Remember how much of zinc they use? 0.2 gram. 2 ml ammonium buffer. This one are just buffer solution. Are you getting it? What is a buffer? Buffer is something that helps to what? To resist a change in pH. You know they do any work there. When I be chemistry student, I don't learn buffer before. Are you getting it? Its work, it does not affect the titration at all. Its work is just to ensure say the pH remain okay. Are you getting it? 2 drops of modern black. Modern black is what? Is an indicator that is used in this titration. We are added and titrated until the color changes from white red to blue, and it was repeated, and the average endpoint was recorded as 15.8 mil. So you have your titer value, my dear student. Right, titer value 15.8 mil. Now calculate the factor for the 0.05 molar disodium EDTA used. Now, my dear student, what is the formula for factor? We say factor is the weight, standard weight, which was given, standard weight, that is formula for factor. This standard weight, it can be anything, just so long you know what this standard weight mean. All over titer value times milli times the milli equivalent. Are we getting it, my dear student? Now, the most important thing, you already know the standard weight. They gave you the standardization of 0.05 molar sodium EDTA was carried out using 0.2 gram zinc sulphate. So the standard weight you are talking about, standard weight, is this 0.2 gram zinc sulphate heptahydrate. You must write it out. That is the standard weight because they tell you, say you weigh 0.2 gram of zinc sulphate heptahydrate. Are you getting it? All these ones are just 2 mil, these ones are buffer, they don't really matter. Then the titer value is another parameter that you need. So titer value is 15.8 mil. Now, the question now is calculate the factor for the 0.05 molar disodium EDTA. Now, what among everything here, what you know get to calculate factor, say standard all over titer value times milli equivalent. You don't know the milli equivalent. Now, sometimes this titer value they not give you. Now, your experiment you go do and get it to then divide. Are you getting it? Now, how you not think they get the milli equivalent? A very simple something, very, very simple. See, follow me. Make we do one together. Follow me, we'll do one together. Are you getting it? How to get the titer value? They gave to you that 287.5 grams zinc. I suppose do this thing first. Okay, what you go happen is I will clean this one. You already know what I wrote here, right? You already wrote it down because I will be needing the information here. I don't want to be going back and forth. Okay, now write this whole thing when there to calculate the titer value, the milli equivalent. Now, what I want to teach you. So write everything when you get here. So you will come write down 287.5 gram of zinc sulphate heptahydrate gave you 1000 mil 1 molar sodium EDTA. Now, see what you are going to do. A very simple thing. Listen, see what you are going to do. See what you are going to do. Why they call a milli equivalent? They call a milli equivalent because it's 1 mil of the concentration of what is given to you. That's why they call a milli equivalent. 1 mil of the concentration of the EDTA. This is when they say now the EDTA. Now the sodium EDTA now they here. This 1 molar sodium EDTA. Now this thing when they here. So what you go do now to convert this entire place when they here. Are you getting it? To 1 mil, convert this 1000 mil to 1 mil. That's why they call it milli equivalent. Convert this 1000 mil to 1 mil of this concentration of sodium EDTA. This Na2HY is sodium EDTA. That's what I'm trying to tell you. Disodium EDTA. Disodium, 2 sodium. That's why what you can see here. 2 sodium EDTA. H2Y. They use sodium EDTA as this H2Y here. So what you will do now is say you will convert this 0.5 mol, this 1 mol molar here, 1 molar concentration to 0.05 molar. So our target now, when they just give you this question, first of all, this thing when they give you here, compare them. This one when they give you, are you getting this 1 molar? Look out for the question where it is. Now be this. So we need to convert this 1 molar to 0.05 molar because now 0.05 molar you use. And always know, say this 1000 mil, you will convert that to 1 mil. So how do we convert? And another thing you should know is now 2 things. Now you they divide. As you they divide here, this part, you they divide this part too. Listen, no. As you they divide this part, you they divide this part too. But now only one thing. Now 2 things now if you divide here. If you divide this one volume, 1000 mil, if you divide the concentration, 1 molar. But if you they divide volume here, you know if you divide concentration here. Now only one thing for here if you divide at once. As you dey divide one thing for here, you must also use that thing when you dey divide, take divide something for here. But now only one thing at a time if you divide for here. You no fit divide your two at once. So I say our target na to reduce this 1,000 mil to 1 mil. How go fit reduce this 1,000 mil to 1 mil? By dividing by what? 1,000. You see, say as I divide by 1,000, I go fit come here, come divide here by what? 1,000. But I no go touch here. Are you getting it? Because now only one thing for this side, now you fit divide, and then one for here. You no fit divide your two at the same time. So this one go cancel this. Now, when this 287 divide 1,000 mil, wetin e go give to you? 287.5 divide by 1,000 mil. That one now will give us 0.2875 gram zinc sulphate heptahydrate to give us this one now. We don't use 1,000. Do you know the reason why I divide here by 1,000? Because we know say if 1,000 divide here, it go turn to how many mil? 1 mil. You understand what I do, Abi? Because we say we must convert here to 1 mil. So what we take divide this 1,000 mil to convert that to 1 mil and 1,000. So here now becomes 1 mil, 1 molar sodium editate. We don't already convert this one to 1 mil because I told you that mil equivalent is 1 mil of the concentration given. The concentration given is 0.05. So we must convert this 1 molar to 0.05 by dividing. How go fit convert 1 molar to 0.05? First, we fit start by dividing by 2. If we divide here by 2, it will give us 0.5. Let's start from there. Then we'll divide here by 2 also. Are you getting it? So when you divide, everything you get here divided by 2. That will give us 0.14375. Zinc sulphate. You must do one like this, so you follow it up like this. Is that okay? 1 mil. This one cancel this one. This will give us 0.5. The reason why I have to divide by 0.2 is to ensure that we are having 0.05. But what we get now 0.05. So what we go to divide 0.5 when we give us this 0.05. Now this 10. If you divide by 10, divide here by 10 because of space. We divide here by 10, here will give us 0.014375 zinc sulphate heptahydrate. You see, say when I don't divide this one now, this side, I divide this side, they divide here, but I know they touch this 1 mil because I see only one thing at a time. If you divide for this side, will be equals to what? 1 mil. 0.0 divided by 0.5 rather divided by 10. That one will give us 0.05 molar sodium editate. Now the milli equivalent be this. So the milli equivalent, it just tells us 1 mil. What mass of this zinc sulphate react with 1 mil of the concentration given? Emphasis, it is not always 0.05. Okay, let us assume the concentration given is 0.1. The only thing you just need to do now is to divide this 1 molar by how many? 10. Because you know if you divide this 1 molar by 10, it will give us what? 0.1. Then you come here also divide here by 10. This 1,000 mil also, you must ensure that the 1,000 mil is in 1 mil by dividing by 1,000 first. Is that okay? So this value when you get here now be your milli equivalent. This value here now be your milli equivalent. Is that understood? So my dear student, what is our milli equivalent in this particular question? Milli equivalent is 0.014 if all my calculations are correct. 0.014375. Are you getting it? Gram. That is your milli equivalent. Now, the standard weight is this 0.2 because they gave you 0.2 gram. So standard weight (0.2 gram). Is that okay? Then another thing again is what other thing again? Title value was given as 15.8 mil. So we have volume 15.8 mil. So my dear student, our factor now will be equals to what? We said standard weight 0.2 divided by milli equivalent 0.014375 times title value 15.8 mil. Can just remove the mil. So what will be our factor for this question? 0.2, 0.014375 times 15.8, which will now give us 0.8806 approximately. So this is our factor. Is that okay? This is our factor. So any questions they give to you, you must be very, very careful. You must be very, very careful. I will explain something towards the end, but this is how to follow through for this particular one. Now, the next question is, now you have calculated the factor. What is the factor even? I don't want to go into explanation of what the factor is. The factor is like a correctional measure, but I don't want to go because of time, all right? Now, that factor now you can't use. The factor now means say this thing when you give, because you actually want to use, listen, you actually want to use this sodium editate. Are you getting it? To know the amount of magnesium sulphate. This factor when you calculate now be the correction, all the panabitting when we don't do for this sodium editate to ensure say this sodium editate they okay. Now why they calculate this factor? So anything when don't dey wrong before for sodium editate, this factor will correct am, make am dey okay, perfect. So that this sodium editate now you will come use take get the amount of magnesium sulphate. The thing when you see here, this thing, just this magnesium sulphate, na wetin we dey look for. But we wan use sodium editate take look for magnesium sulphate. We can't look sodium editate with one eye say sodium editate, this thing resemble wetin not too dey pure. Make we try correct am. Then they now use this zinc sulphate. Are you getting it? Take correct sodium editate. That factor now of 0. Factor when you calculate, be the thing, the panability, all the teaching, everything when they say we do to this sodium editate to ensure say they all right. So then we will use sodium editate, they get the amount of magnesium sulphate present there. Is that okay? Now, same process is what we have here. Now, listen. We have the next one. Assay of magnesium sulphate. Pipette 10 ml equivalent to 0.06 gram of magnesium sulphate into a conical flask. Because they already gave to you that the 10 ml is equal to this. But most times, they will not give you. Now, which I thought I will explain. But they don't already give you. Now, what is your calculated weight? What is the formula for calculated weight? We say milli equivalent for this one. Calculated weight, Abi, is milli equivalent, which you can write as MEQ, times your title value times your factor. Your milli equivalent, you don't know. Your factor, we don't already calculate factor to be what, my dear student? What was the factor? Now, this factor when you can't get from here now you will use to do for that one. Are you getting it? The factor is 0.8806. So 0.8806. The title value, they will give unto you. Okay, they don't give you title value. Now, this one now you will call calculate your title value. Now, this experiment you will come do. So first, pipette 10 ml, which is equivalent to 0.06 gram of magnesium sulphate into a conical flask. Are you getting it? Add 3 ml of the buffer and 2 drops of modern blank and titrate with you still use 0.05 molar sodium editate until this one. Record your titer value and repeat the titration. So you have a titer value. Let's assume say you don't do the experiment. Your titer value is, let us say, 10. I'm just saying, 10 mil. You don't do the experiment. Now you go do one for lab. Let us say it's 10 mil. So the next thing we need to calculate now your milli equivalent. You can't use this thing again. The same way when we do earlier, take calculate your milli equivalent again. Now, what did they give to you? They give to you, say, 120.38 gram magnesium sulphate is 1000 mil 1 molar sodium editate. We'll call calculate our milli equivalent again for this particular one. We want to know how much of this magnesium sulphate react with 1 mil of 0.05 molar disodium editate. Because what you carry out your titration as 0.05 molar disodium editate. So we want to know how much of magnesium sulphate will react with 1 mil of 0.05 molar disodium editate. How do we achieve that? First, you convert this 1000 mil to 1 mil by dividing here by how many? 1000. Dividing here by how many, my dear student? 1000. So when this cancel this, that will give us 120.38 divided by 1000. That will give us 0.120 gram of magnesium sulphate to give us 1 mil 1 molar sodium editate. You are now going to think, what are we going to divide what are we going to divide what are we going to use to divide one that will give us this 0.05? Because we said we must convert this thing. This disodium editate, now this thing, they just use an Na2 disodium editate. So we must convert this 1 molar to 0.05 molar. How do we do that? We already did something like that. You can divide by 2 and then by 10 again. Dividing by 2 and by 10 again still means divided by 20. So if I divide here by 20, I will also divide here by 20. When this cancel this is going to give us 0.120 divided by 20, which will give us 0.006 gram of what? Magnesium sulphate will be 1 mil 0.05 molar sodium editate, because 1 divided by 20 will give us 0.05 molar. Is that understood? So this is now our milli equivalent for this particular question. Are you getting it now? So you are now going to, because this was telling that 0.06 gram of magnesium sulphate reacted with 1 mil of 0.05 molar sodium hydroxide. Is that okay? That's just the meaning. So coming here, you are now going to say calculated weight would be equals to milli equivalent times your volume, which is your titer volume or titer value, times your factor. So our calculated weight, milli equivalent is what? 0.06 gram. 0.006 gram. So 0.006 gram. The titer value, I say titer value now the one where you get from the experiment, right? Which is your 10 mil. So we have times 10 mil times the factor. The factor is the factor you already got from this first one. Are you getting it now? The calculation for this first one, now that factor you can use. So what is the factor? 0.8806. Abi? 0.0 exactly. So our calculated weight now will be 0.006 times 10 times 0.8806. So calculated weight would be equals to 0.052 gram. Are you getting it? That is calculated weight. Is that okay? So we are trying to know how much of magnesium sulphate is actually there. So this amount you calculated is of magnesium sulfate that was present there. We want to know how much of magnesium sulfate there using standard sodium editate. So sodium editate is like the one when we say we don't pan and beat. Now that one, I tell you that one we they try use to get magnesium sulfate. All right. But they give say this thing, see where the thing dey o. Say calculate the percentage purity of magnesium sulfate. They give you from the question say this 10 mil when you pipette, we dey use eye dey look am. Say this 10 mil is equals to 0.06. So, but when we come do the experiment, that is because we know they sure. Are you getting it? This 0.06, you know they sure. It's something that you don't know. It's an unknown. But we don't estimate and say now 0.06 suppose dey there. Oh yeah, now we'll carry out the experiment. We can't carry out the experiment, can't discover say what actually dey there now 0.052. They now say calculate the percentage purity. So percentage purity now will be your calculated weight all over your standard weight. Now, the standard weight is not that first standard weight, though, is this one here for this particular one, because this experiment is a different one entirely. What we did here now just the factor we need from this experiment, nothing concern us for this experiment again. Are you getting this calculation? Nothing concern us again, now just the factor we need. Is that okay? We are now using that now to work with this one. The standard, because they gave to you now 10 mil, you measure 10 mil. The 10 mil is supposed to contain 0.06. Are you getting it? But when you can't try the experiment, finish everything, you can't say now 0.05 day. So your calculated weight times all over standard weight times 100%. So your standard weight is the weight you should be expecting, or sometimes some persons will pay expected weight. All right? Calculated weight all over expected weight times 100%. Whichever one when you use now, your headache. Percentage purity, my dear student, will be calculated weight is what? 0.052. Expected weight is what? Is 0.06. Everything times 100%. So percentage purity now will be waiting. Percentage purity will be 0.052 divided by 0.06 times 100%, which gave us 86.6. So I'll tell you that 6 is repeating itself. Percent weight by weight. You must put your weight by weight. Why? Because calculated weight is in weight, in gram. Expected weight is in weight, gram. So that is why it's weight by weight. So 86.6% weight by weight. Now the next thing is discuss your result considering the safety if the BP standard is 99 to 100%. Now you are not going to write, say discuss. What you are going to write under here is this. You must do it too. What you are going to write is this. The VP specified that the product is safe when it has a range of percentage purity between 99% to 105%. From the experiment conducted, we could see that the percentage purity is 86.6%. Hence, it did not meet to the expected percentage purity. Hence, the product should be discarded or kind of should not be used, and it's not safe for use. Rather, you can put it's not safe for use because BP say 90, which they get now with 86. Let us say the value when we get here now like 91 also. We say that okay, it is safe for use. But because it no reach, we say it is not safe for what use. And that is everything you just need to do in this particular experiment. So it's a very, very simple thing. Now, there's something I want you guys to take note of before I leave you finally. Now, listen. There are cases where they may say, okay, let me come here. There are cases where they may say this 0.06 gram. Let me leave it. But there are cases where they may say this 0.06 gram, they may not say 0.06 gram. They may just give you that weigh 0.6 gram of magnesium sulphate. They may just say weigh 0.6, but since they already give to you people, maybe they already prepared everything. But they may just say weigh 0.6 gram of magnesium sulphate. Weigh how many? 0.6 gram magnesium sulphate into 100 ml volumetry flask and make up to volume. So you weigh 0.6 into 100 ml volumetry flask and they say make up to volume. Perfect. They will now say pipette 10 ml out of the 100 ml that you already weighed, or you already prepared. Pipette 10 ml out of the 100 ml. Remember, I said there are cases where they will just say weigh 0.6 gram into 100 ml volumetry flask and make up to volume. Then from there, pipette 10 ml. So if we are to pipette 10 ml from this, if 0.6 gram is in 100 ml, the 10 ml you pipetted will be equal to what? X. Are you getting it? 0.6 gram is in 100 ml because they say weigh 0.6 gram and put the 0.6 gram in 100 ml volumetry flask, make up to volume, then pipette 10 ml. If you are pipetting 10 ml, if 0.6 gram is in 100 ml, the 10 ml you prepared will be equal to what? X. Cross multiply 100x will be equal to what? 0.6 times 10. To get x, divide both sides by 100. So x will be 0.06 gram. It meant that the 10 ml you pipetted contains 0.06 gram. The question may also come out like this. So in a situation where they say, first of all, put out for here. Put out for here. Then take a percentage of this one. You should do this calculation. Maybe they say 0.6 gram in 100 ml. Then take 10 ml of that. You should do this calculation. So in that case, before you can get the expected weight, which is 0.06, you should do that calculation for that particular one. But that is basically, this one is basically everything that you should do. And this process is for almost every experiment. Apart from experiment that does not involve you standardizing, there are some experiments that does not involve you to standardize. Are you getting it? So those ones, you just go straight, calculate your milli equivalent and factor. Most times you just say factor is 1. Or if there's no factor, don't put factor there. Just calculate straight without using factor. It will be milli equivalent times theta value, no factor. Are you getting it? There are some experiments like that. I don't know if I have time to go through one experiment like that. So that will be that for now. Thank you very much for your time. We'll see you in the next one.